So evolution of temperature in the post-glacial period, this is glacial, and everything after it is post-glacial, according to Greenland Ice-cores. Here, air temperature in Greenland in degrees Celsius. So we see the glacial and we see the Holocene. Most people recognize the Younger Dryas as an ice age. Well, first thing is it starts out really with a low temperature, which certainly is worth an ice age. It's roughly the temperature the same as during the glacial, the ice age. But it's rising temperature and it's even extreme rising temperature. So it's strange to call it just bluntly an ice age. In fact, it's a 1,100 year extreme rising of temperature. Anyhow, the onset, 12,900 years ago, is associated by consensus to a meteorite impact. Uh, in fact, that is strange because a meteorite impact should uh, cause cooling, and what happens is warming and even extreme warming. So, in a way, consensus neglects what happens before, which is extreme, and that this is quite some time before. It's almost 15,000 years ago that we, the Earth, Greenland, but this is true for the whole planet, experience extreme warming, and we should understand why this extreme warming takes place and why, after taking place, it goes cooling for well over 1,000 years. We claim after the initial warming, the amok shut down, the Gulf Stream, and possibly other streams, currents shut down, and Greenland didn't receive any more the warmth from the equator, and it cooled down, extreme cooling down. But here, most extreme, second extreme, a third extreme cooling. So in fact, the cooling happens in the period before the Younger Dryas, which is recognized as an ice age. So we will focus on this rising because that's the start of the extreme temperature changes. It was like this in the glacial. There was an extreme rising of temperature, almost as much as what we experienced in the Holocene, and then there was a significant drop. And then since the supposed meteorite impact temperatures rose, but they should cool further if it had been a meteorite impact. So what we claim is it wasn't a meteorite impact 12,900 years ago. It was, in fact, the picking up of the AMOC, and the AMOC picking up could warm the Earth once again. But there's another factor. There's another factor that we should understand, that we need to understand, because this is extreme. We are here right now, probably a bit higher. I'm not even sure, because this is an image of a few years ago. At this point, we are looking at the temperature change and dust Vostok Antarctica. So that's in the southern hemisphere. Greenland is obviously in the northern hemisphere. So we look now at a much larger period of 420,000 years. 0 years, 400, 420,000 years. And the Holocene is now here. In Antarctica, it's right now, or for the last, uh, let's say, 10,000 years, it's around 0 degree. Celsius. So what is important here is that it was it started out with an extreme temperature rise. This is extreme. It's from some of the lowest temperatures of the last 420,000 years to close to the highest temperatures of the last 420,000 years. But there's more. So this obviously was the Ice Age, and this was the earlier Holocene, not Holocene, Interglacial, because we only have one Holocene, which is an interglacial, and this is an interglacial, and this is an interglacial, etc. So roughly 100,000 years ago, or roughly 100,000 years before the start of the Holocene, we had another Holocene, but it is an interglacial. So we should understand this cycle of 100,000 years because obviously if we would get into an ice age again, we would have big troubles, especially since, let's say, after former Holocenes, the temperatures crashed out of the interglacial they were in. So it would destroy our agriculture, it would destroy the West if it were. I'm not claiming here it will, but all over the history of the last 420 years, 420,000 years, we see we crashed over and over out of our Holocene. So to understand this cycle is of extreme importance for, let's say, the existence for about everything. For us, 8 billion humans, 8 billion here. We have no evidence of how many millions or billions there were here, and certainly not how many there were in former ice ages. We could have some idea about the last 50,000 years. But as said, our history is roughly about the last 5,000 years, which is only half of this interglacial that we call the Holocene.